All right, let's continue with our lesson 8.2 notes packet. So here we are given the same instructions as we were in problem number 1, only now we're looking at problem number 2. We're going to need to find the vertex. We're going to need to find the axis of symmetry. We're going to need to label those on the graph. We didn't label those before, but it'll be good. We can draw them here. We're also going to practice finding our domain and range, and we're going to write our own table. So we already know, without doing any work, that this number right here is a negative value, which means that our graph is going to open downward. All right, so that's just a series of checks to make sure that we're doing things correctly. It's always nice to know when you do things right. Feels great to be able to turn in your paper and say, hey, use mine as the answer key. Yeah, we've all loved that. So let's type this into our calculator. I have to wake mine up. And let's push Control Doc. And we're going to graph on a new coordinate plane. So let's go add a graph. And in that graph, we're going to type in the equation that we were given in the problem to begin with. So this is where you have to make sure that you do use the negative symbol. And your negative is down here next to the period, and that's what you use, not the minus. Okay? So let's use negative, and it's really tiny, it's hard to see, 2x squared. And now we use the minus, now we use the subtract, and that's much larger, it's easier to see on your screen. 5. Push enter. And so our graph is here, but it's all the way at the bottom of your screen. And your screen here on the calculator is reflecting so brightly that it's really hard to see. So that's going to be okay. We're going to look at the table anyways, and that'll be very easy to see. So Control T. And that will help us out. All right, so before we go use the table, let's push this to the side and go find our axis of symmetry and our vertex. We've just got things set up nicely. So for our axis of symmetry, we remember that it's x equals negative b over 2 times a. So let's go back to our original problem and make sure that it is even written in the right format. So my standard format is ax squared plus bx plus c. And according to this problem, I'm missing just a little bit of my equation, and that's okay. We can go find it and put in the appropriate values. So here's an x squared term, so that's in the right place, negative 2x squared. And now I need a b times x. I don't have just a simple x in my equation. There isn't one there. So you say, hey, what could multiply to an x and make it disappear? 0. 0 times x. So this disappeared. And then I have a plus c, which is just a simple constant, and that's a minus 5, just a simple constant. Very good. Now we can use that equation to help us with finding our axis of symmetry. So a is equal to negative 2, b is equal to 0, and c is equal to negative 5. Let's put those into our axis of symmetry equation. So I have negative times my b value of 0 divided by 2 times my a value of negative 2. You might say, hey, what's negative 0? Well, what's negative nothing? Nothing. It's just nothing. So what's 2 times negative 2? Oh yeah, negative 4. And then 0 divided by any number in the whole wide world, 0. So my axis of symmetry is x equals 0. That is where my graph is going to cut itself perfectly in half. Now let's use that axis of symmetry x value to find our full vertex coordinate point. So we have our f of x equation, or we can use our original equation. It's a little bit smaller, a little more simple to work with, and let's do that. So f of 0, that 0, way over there, f of 0 is equal to negative 2 times 0 squared minus 5. Remember, use your parentheses. All right, again, you can put this into your calculator if you're tired, or it's been a long day, or adding and subtracting just isn't your favorite. Control Doc, calculator. Let's type this in. So I've got negative 2 parentheses 0 parentheses squared minus 5. Get negative 5. So f of 0 is negative 5. And as a result, my vertex is going to be the coordinate point 0, comma, negative 5. Great. All right, so we had already set up on our calculator the coordinate points with our table. Let's zoom in on that a little. Yeah, that's nice. So now we can write up our own table, knowing that we have to go around, hey, there's 0 and negative 5. That's the vertex we just found. So let's do that. We'll get a couple of points to the left of it, all the way through to a couple of points to the right of it, and see what we get. So let's write these down. I've got the coordinate point negative 2, negative 13, negative 1, negative 7, 0, negative 5, positive 1, negative 7, and positive 2, negative 13. Let's go plot these points on our coordinate plane as much as we can. All right, so let's go to the left 2 units, down, oh, that's only to 10, so I can't plot that point. That's okay. Let's go with our next point, negative 1, negative 7. So let's go left 1, down 1, 2, 3, 4, 5, 6, 7. That works, that fits. Let's plot our vertex, 0, negative 5. Over nothing, down 5 units. Let's go to the right, 1 unit, down negative 7. I love how these parabolas are nice and symmetric. They just tell me that I'm doing things right. And then my last coordinate point, again, it doesn't fit on my graph. And that's okay. So let's bring our curve through these points. There they are. Say, hey, this is my vertex. There it is. That's my vertex. And this is my axis of symmetry. This is the line x equals 0. Axis of symmetry. X equals 0. So that's the line that cuts it perfectly in half. Let's talk about domain and range. So the domain, remember the domain is all of the x values that can be used on our graph. And we said on example number 1 that if you have just an equation, go graph it, every one of these parabolas is always going to have a domain of all real numbers. It's only when you get into story problems that your domain is going to change. And our symbol for that is our fancy double-barred R. Last but not least, let's look at our range. We remember from problem 1 that the range is the y's that get used. And we had said that if your parabola opens down, so all of your curve is below, we use y less than or equal to the height of your vertex. So my vertex height is -5. And that's the number that goes right there. So this is going to be a less than because it opens downward. And this -5 is as tall as your curve gets. It's where it maxes out. It's also the same -5 from your vertex. Okay, now it's your turn. You do problem number 3 and stop the video if you get stuck, or if you get your answer and you're ready for me to check it, bring it up to me.